Hey guys, so I'm making this video and I don't know exactly what it's going to be titled, and I'm kind of thinking through right now what exactly I want to include. But I think I'm going to go over an example that I've done in class, or not in class, in office hours today. And I'm really hoping that this gives you a better understanding of the power of masking and why we expect you to know it, and all the different things that we can do with masking. Because masking is a really broad subject, so I can understand how daunting it might be to learn it. And we might say, oh, you need to use masking for this, and it's like, okay, well, what do you mean I need to use masking? I know all sorts of masking. So I'm not just going to define what a mask is. I'm actually going to go through several examples of different ways to use masks. So let's get at it. Let's start with an array. We're going to call it A. Going to call it A. And this is going to be something like 12, 6, 3, 18, 4. Right? So I've got this array. What should I do with it? Well, let's create a different variable b, and we'll make b equal to 7. Okay? So now I've got a and b, I can create a mask, right? I'm good to go. I create a mask, and I want the locations in A where it's greater than B. So the way I would do that is A greater than B, right? Now, as a note, what does this equal? It equals 1. Remember, that's logical true. So this is saying that 12 is indeed larger than 7. Then is 6 larger than 7? No. 0, logical false. Then we do 3, also not larger. 18 is larger. 4 is not larger. And that is our mask, or that's our M. Now, when we talk about masking, we can mean a whole lot of different things. So, when we used find, we were using find, and then we were providing it a logical statement that looked a lot like this. That is not a coincidence. The input to find most commonly is a mask. So don't think that you haven't learned any masking, because you certainly have. Now, that's our M, and this is going to be our mask. Now, let's do some stuff with this. So first things first, probably the simplest thing to do is to pull out values of A using the mask. So if I want to find out what the actual numbers are, so like obviously, well, I've got that the locations where this is true is this location and this location, and I could use find, and then I could use the results of find to actually get the numbers. Or alternatively, if I just wanted my values, I could just say V is A at our mask, right? And so this would lead to V being equal to 12, 18. It might also be 12 semicolon 18. I'm actually not sure, and you should check it out for yourself, but I'll just assume it's a row vector, and we'll work under that assumption. Now, equivalently, I really want to point this out. This V equals A, where A is greater than B, is the exact same thing. It is the same. It will result in the same thing. Remember that M is exactly this. This and this are exactly the same thing. All right? There's no need to get your feathers ruffled. Now, if you want to create a mask, and if you're going to be using a mask several different times, it might be useful to create a variable. If you're using a mask just once, you probably don't want to, right? And so that is why when we use find, we didn't actually create a mask before using find. We just put our logical statement inside of find. So this is doing the same thing. And it's saying where in A, I want to pull certain values out of A. Where do I want to pull them? I want to pull them where A is greater than B, and that turns out to be the first and third. And I want to pull those values, not or first and fourth location. I want to pull the first and fourth values in A out and put them into V. Now, another thing that we can do is if we have a new variable D, and we say D is equal to, let's say, 16, 4, 1, 1, 8, and we wanted to pull these locations, but the values from D out, we can do a similar thing. We can say V2 is equal to D at our mask, right? And so what would the result of this be? Well, V2 would equal first and fourth location, 16 and 1, right? First location, fourth location. Now, things that are important here. The size of D is the same size as A. They should always be the same size. I think you might be able to get away with not having them the same size, but really, 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 really avoid it. Because the second you don't avoid it, it's going to come back and bite you. I've had it happen to me before, so just be careful that they're the same size. So that covers sort of the first and second thing that I wanted to cover. So this being the first thing, so this is first, right? Pulling from pulling values from an array and using a mask to do that. And this is the second, which is pulling values from a different array of the same size using a mask that was defined originally from an array different from where you're pulling the values, blah, blah, blah. Now, the third way, I think, is what is going to get some of you. And so I'm actually going to give the more, I don't know if it's more complicated, but it's certainly more lengthy. I'll give the more lengthy version first, and then I'll go back and show you that there is another bit of functionality just in case it shows up on the exam. So here's going to be our third example. We're going to define a problem in this example. We're going to say, okay, if my A values are greater than my B value, I need to divide all of those values by 2. So I'll write this down. I want to divide everywhere where A is greater than B. I want to divide everywhere A is greater than B by 2. So I'm using just the divider. I'm just using the slash sign, right? How do I do this? And I want these, and importantly, sorry, I'm going to add this, and these divide by 2 and replace them. So I don't just want to get, what would it be? I don't want to just get 6, 9. I want to get 6, 6, 3, 9, 4. That's my goal. So I want to replace these values from the original matrix. So how do I do this? Well, I have A, and what I do is I say A, where I'm performing the operation at our mask, I want that to be equal to A at our mask divided by 2, right? So this is the part that's satisfying the problem, right? That should be pretty easy to see. And MATLAB has no problem because this is a vector, right? If you just put AM, if you just put this into your command window, the result, like we put up here, right, is 1218. So it takes that, then we divide by 2, and we get 6, 9, right? So far, so good. So what is this left-hand side saying? What is this? Well, it says within A, right, we're going to look for certain locations. And those locations that we're looking for are our mask. So we know that where this is logical true, we want to replace those values. So where this is 1, replace the values with the values on the right-hand side. On right-hand side. So our result, as it turns out, is what we intended. We get 6, something, 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 9, and then let me search up here. 6, 6, 3, 4 are my other 6, 3, right? Yeah. So this is our result, and that is what we wanted, right? That's what I said earlier out loud. So that is one way to use masking with the mask on the left-hand side as well as the right-hand side. An important note, the number of elements that are true in this mask have to be equal to the number of elements that are true in this mask. Otherwise, you'll get an error, I believe. If not, you're just going to get bad numbers. So now the other thing is maybe we want to set these values to 0. So if I want to set the values that are greater than b to 0 and ignore the rest, then the way I would do that is I would say a at m, and this is the fourth way to use masking. A at m is equal to 0. And so you can assign a scalar value to this, which is in fact a matrix. You can assign a scalar to the vector, to the matrix. That will work just fine, and MATLAB has no problem replacing all this. So if I perform this operation, and I have no clue why that arrow is going to be so long. If I perform this operation, I'll get 0, 6, 3, 0, 4. Now, I really, really, really highly encourage you to try all of this yourself and think about how you could have used this on your MA. Masking could have gotten rid of so many if and else statements on your MA. I would really highly encourage you to try to do the MA with the fewest number of if and else statements you can while still satisfying all the criteria, because that is going to be incredibly good prep work for masking and questions that you might see. With all of that said, I think that I might have actually covered this quicker than I had expected. So if you guys have any questions, leave them in the comments. I'll probably check back. But I think that this is a pretty concise sort of description of the different ways that we can use masking. I'm trying to think if there's anything else that I've forgotten, but I think we're actually in pretty good shape. Yeah. So hopefully this gives you a good intro to masking, And as always, we have online office hours, we have in-person office hours, so please stop by. Anyways, talk to you guys later.